All right, hello everybody. This is going to be a quick explainer of question 1 for quiz 4. I'm not going to do question 2 because it seemed pretty easy. So get off the bat here. If r squared for the least squares regression line for this data is 72%, what is the correlation? Correlation meaning what is our r value between lunches and helmets. So lunch being our x value, helmet being our y value. So since r squared is simply our r value squared, to reverse that, you can do the square root of our r squared value, which is just going to be the square root of 72%. And that's going to give you 0.8485. And that's not your r value because you have to consider this in context. Your r value, if you square something and it's negative, it will make it positive. And so since we have to take that into consideration, you can just look at it in the context of our data up here, and you can tell that clearly the correlation is negative. So our r value is actually going to be negative, and it wants to round to 3 decimal places, 0.849. That is our r value. Simple enough. I don't think we should have any problems with that. Next is B. So let's see, calculate the slope. It wants us to calculate the slope. So let's just write down our data here just so we can kind of do it. Our mean of x is 30.9. Standard deviation of x is 26.8. Our mean of y is 38.8, and our standard deviation of y is, I forgot what it was, 16.7. And I mean, it doesn't really matter if you change these into like percentage points, you know, because as long as the ratio is the same, it's going to be okay. So find the slope. So slope is b1, and this is going to be equal to the standard deviation of y over the standard deviation of x multiplied by our r value that we found. So it's going to be negative 0.849 times 16.7. Gosh, I can't write 1 today. 16.7 over 26.8, which is going to give you a value of, let's see, equals negative 0.529. This is going to be our slope, and our slope is negative 0.529. That is the slope. Now we need to find the y-intercept, which is b0. And we can do this by using the slope that we just found. And the formula for that is just it's just going to be your the mean of y minus your slope times your times your mean of x. So in this case, that's going to be 38.8 minus negative 0.529 times our mean of x, which is 30.9. That's going to give us a value of 55.1461. Wants us to round that to 2 decimal places, so 55.15 is going to be the answer for this here, excluding that little r that is right there. I don't like that. Get out of here. Okay, next question. Interpret the intercept of the least squares regression line in the context of the application. For neighborhood with 0% reduced fee lunch, we would expect what percent of bike riders to wear helmets? So interpreting this is pretty simple. It wants to find where 0% lunch, which is going to be here. So that's essentially our y-intercept. And you literally can just use the y-intercept. So the percentage point that this should intercept at is 55.15, which we just calculated up here, if you remember that. So 55.15% should be our answer for this question. Next question, intercept the slope for every additional percentage point of lunch, there is a decrease or an increase of how many percentage points in riders who wear a helmet. Note that this says percentage points. I got this one wrong and had to use my second attempt because it is different from percent. It's just, that just screwed me up, so I figured I'd say it. So thinking about this in the context of our question, we have our y and our x, and it wants to know the slope. So for every one additional point we go over, our slope says that we're going to go down 0.529 percentage points. So this length is going to be that there. So there's going to be a decrease of 0.5. This is not negative because you're saying it's decreasing, so it's 0.529 percentage points going down, which we indicated here. That is the answer for that question. Now, this next question, excuse me, wants us to calculate the residual. So to do that, it wants us to calculate it at 40% here, as you can see. So to do that, you are going to take your what it thinks, so like 40%, you're going to take that and you're going to subtract from that what our expected value is based off of this slope and y-intercept creates a line. So based off that line, what is the y value at 40%? So what we're going to do is, I wish people would stop texting me right now. We're going to do the y at equals our slope, 0.529 times our x, which is 40, plus, let me mute my computer real quick, plus 55.15, which is our y-intercept. And this is going to give you a y of 33.99%. And so what you're going to do is you're going to do 40 minus 33.99%. That's going to give you 6.01. And so your residual is 6.01. So that's your first part of this question, 6.01. Interpret the meaning. There are blank percent more riders wearing helmets than predicted by the regression model in this neighborhood. And it's literally the same thing. It's like this is the percentage above what the actual, so like this is the actual and this is our, say this is like our expected, this distance here is 6.01. So essentially it is just 6.01% more bike riders wearing helmets than predicted by the regression model in this neighborhood. I hope this helped somehow. Good luck.